Okay, good morning. This is week 3. I want to go through quiz number 2 first. I realize student has issue with it. Okay, so quiz number 2, it states that, by the way, this solution is uploaded onto Avenue to Learn. Okay, but I want you all to listen to what I have to say first. So what we have down here is a statically indeterminate structure made of steel and brass joined at point C, and also given the Young's modulus of steel and brass. Okay, determine the force at point D such that the stresses in this section BC is minus 1A naught, and it depending on your student number. So BC is under compression. So the question want you to find the reaction at point A and the reaction at point E, as you can see. Okay, and the deflection at point C. So we want to find the deflection. So I scan briefly the answers that you all have. A lot of students make a mistake by not incorporating the reaction force or the redundant force during the analysis of the 170 megapascal or 1A not megapascal. I will elaborate that later, okay? So for this case, what I did is I remove the support at A. Okay, so we remove the support at A. So once you remove the support at A, okay, it's like what I taught you, right? The first step is to remove the support. Okay, so when I remove the support, we allow the structure to deflect. Okay, we allow to deflect. So support at A, so deflection AB, no deflection. BC due to 67, CD due to the 67, and then DE have to include the FD. Okay, now this FD direction, I did not know whether is it going towards the right or towards the left. Okay, I just guess it's going towards the right. If you do either way, the math will correct it by using plus minus, which I will show you. Okay, so don't be afraid. I know you are new to this. Okay, but I did not know when I was your age. Okay, so most of you are less than 30. Okay, I am close to 50 now. Okay, and at the age of 50, maybe 3 to 4 years ago, I learned to trust the physics and the math. Okay, when the physics says positive, you trust it, and the math outcome is either direction, you have to obey. Okay, trust it. I did not, maybe until 5 years ago, and I want you to trust it when you are young. You are 30. Most of you are below 30. Don't learn from me, man. I discovered it when I'm so old. Okay, listen to me. Okay. So you calculate all the deflection, then you sum up the deflection due to the load. Okay, so we do this. Then, like what I told you in class, you calculate the deflection due to the redundant load. Okay, so now I assume the redundant load pushing outwards, like what I told you guys, right? If you're climbing a wall, your hand will push outwards. Okay, I assume it to be outwards. Okay, now another reason why I assume it to be going outwards is these two forces, right? I assume it to going what? Inwards. Okay, going towards the right. So if I assume both of them going towards the right, I will assume this one will be going towards the left. Now, if we were to assume this way, if let's say we assume FD to go this way, right? We don't know, is the 67 greater than FD or FD is greater than the 67? We don't know. Okay. If that's the case, assume it to be going outwards is fine, or going inwards is fine. Okay, as I said, later on the math will correct it. Okay, so for my working, I assume it to be going outwards. Okay, so both are positive, they are going to induce tensile stresses. Okay. Then the next thing that we do, right? So this is the equation that you get from equation 2. This is due to the redundant redundant load. Okay. Then you add both of them. Okay. So like what I've taught you guys before. Okay. Everything is the same. Okay. Then you form this equation over here. Right. Now, this is where a lot of students make a lot of mistakes. Okay. Stress VC is minus 160 times 10 power 6. But you have to remember, stress VC is due to the 67 and also due to what? Due to the redundant load. Okay, and I saw I have a glimpse of the first 13 submission. Okay, based on family name, I realized this is missing. Okay, now why this has to be considered? Okay, if you look at the example that we did last week, okay, like this one, I know this one is involved heat, right? You have to consider, right, the load. Now this is calculated deflection, but stresses is going to be similar. Okay, you have to consider the load induced by the what? By the heat, and you also have to consider the load that is what? Induced by the redundant force or the redundant reaction. Okay. So from here, you form an equation, and you can solve for RA. Okay, you can solve for RA, but you have to consider the RA. Now, remember what I told you guys, right? Initially, we guess RA to be going outwards. Remember? Sorry for jiggling so much. We assume RA to be going outwards. Okay. After we plug in the expression over here, RA becomes what? Negative. When it's negative, it means the direction is wrong. So down here, you flip over. This is what I mean. You have to trust the math. Okay. The problem is if you don't trust the math, that's where there's issue. Okay. And then from here, okay, we use equation number 3, which is this expression, to calculate what is your FD. And we realize that FD, we also guess the wrong direction. So that's why I flip it over. Okay, that's what I mean trusting the math. Okay. Now, as I said, I saw a lot of mistake, okay, done here. Okay? A lot of students did not consider the reaction at point A. Then from here, you calculate your reaction at point E. Okay, so reaction at point E, you apply static analysis. Now, when you apply the static analysis, okay, you have to follow the corrected direction. I repeat again, when you do static analysis, you have to apply the corrected direction, or not, everything will go wrong. Okay, everything will go wrong. Then finally, you can calculate your RE. Okay, I assume the RE is going upwards, okay, and it's positive, so it's correct. Now, deflection at point C, if you look at the marking scheme, okay, the deflection of point C, I only put 1 mark, okay, because there's a lot of things to consider, and you are new to it, okay. So now, we would like to calculate the reaction at point C from point E. Okay, so from point E means E stays. Okay, we want to calculate C based on point E. Okay, the reference means the reference is at point E. Okay, so you have to consider the deflection due to the load at DE, deflection of the load due to CD, and the redundancy due to CE. So why C? Okay, So now, remember, we say that this is fixed, right, from point E, right? So now we know that we have a load here, we have a load going this direction. Okay, this is our point A, point B, point C, point D, and point E. And then we have a redundant load, that is going, I forgot which, the redundant load that is going this way, RA. Okay, the redundant load is going this way. So from point E, you have to consider the entire deflection of this part. Okay, I'm sorry, for point C. Okay, so that's why you have to consider deflection of DE, deflection of CD, and the reaction of the redundant C due to RA. Okay, RA is the redundant load. Okay, so you calculate the value is 180.987 times 10 to the power minus 6. Now, I did another thing for you all to see. Now, what if we take the reference from point A? So if we take the reference from point A, what it means is this. Now, A is what? The reference, we want to find the deflection of C. Now, before I go on, the deflection of C is positive 180.987. Positive means what? Tensile, means it's going towards the what? Towards the left, tensile, okay? Over here, when I calculate at point A, the reference at point A, okay, the deflection of C should be in the negative if it's the right answer. And guess what? It is negative. Okay, so you calculate a deflection either from point A or from point E, your answer will be what? The same. Okay, for my case, if you were to ask me which way to take, which one is better, okay, if you look at the analysis, right, if I were to remove from A, right, so the support at A is missing now, right, means E will always be my reference. If you ask me which to apply, which reference to apply, I will use this one. Okay, I will not use this one because over here I have to reform all the equation. The loading is different, right? Different in the sense that if you were to calculate your deflection, whether you remove from point E or point A, right? Your equation of the deflection are different. Okay, so as I say, the part that is a bit you are not sure is this part. Okay, you have to consider the redundant load when you calculate the stress. Now, I've uploaded the marking scheme also. Now, the marking scheme, okay, for the marking scheme, I want you to take note, okay. I have removed E, okay. So I did the opposite, okay. So I remove E for the support, okay. So I did not write down, but I remove. But guess what? The answers are all the same. So whether you remove your redundant you remove E support or you remove the support at A, it is the same. Okay. Question so far? Anyone, please? Anyone has any burning question to ask? You can ask.
Could you please repeat why, when finding the stress, we do not incorporate the force at E, the reacting force at E?
Because at E, right? Okay, okay. Let me correct. So you mean for this equation, why I don't correct at E? Yes or no?
Yes.
Right. This is because, right, E will not do anything to BC. And I remove the support at point A. Okay, at point A, I remove the support, yes or no?
Yes.
Right? So either I do this or do this, it does not matter because this is, for this case, this is fixed.
Okay.
Okay, that is the only reason. Okay. Right.
Okay.
Anyone else? Thank you, Alex, for that question. Anyone else?
Can you also go over one more time when you're calculating the deflection of C and how are you choosing what force will be there and what will not be?
So if you look at deflection of, okay, the deflection of C, my reference is at point E, right? right? So this part will affect where C is, yes or no? Because the reference is at point E. If
I see.
I take the reference,